that we've learned indices, it's only natural that we move on to standard form. Standard form would be when you want to express a large or a small number such that, okay, a is a number that is more than or equals to 1. Please note that it shouldn't be a decimal like 0 point something something or negative, okay? It will be a positive number that has, which is at least 1, but less than 10. Okay, so this is how you express the standard form, and n is an integer, which can be positive or negative whole numbers. Now, for example, try 10. Okay, you want to express this number in standard form, right? So now, if you want to express, for example, 10a in standard form, what you want to do is there is an imaginary decimal here, right? And you want to move it forward. So we divide by 10, 10 square, 10 cube, 10 to the power 4, 10 to the power 5. So what you have is 3.78 times 10 to the power 5. And this, you want to move this decimal all the way here, right? Such that this, the first digit will be a 9 to fulfill the criteria. So 10 to the power of negative 1, because this means divide by 10, right? 10 to the power negative 2, 10 to the power negative 3, 10 to the power negative 4, 10 to the power negative 5 times 10 to the power negative 5. Okay, so if you move this side towards your right, then you get 10, you have negative power. So 10 to the power negative 1, negative 2, so on and so forth. Okay, and just to mention, okay, intuitively, this is a big number, right? So of course you will expect a positive power here. And as for a very small number, okay, because it's like 0.0000 something, so a small number, intuitively you should have a negative power. Okay, just to do a quick mental check whether did you get it right or not. Let's move on to 5F. For 5F, one error that I can foresee will be students will be very tempted to do the subtraction here by themselves because it looks so straightforward, like you just use 5 times 10 to the power 6 minus 5 times 10 to the power 5, then what you do is just, then you'll get like 5 times 10, right? Because 6 minus 5, then you just left 10 to the power 1, but this is wrong, okay? Please do not do that. When you see multiplication with plus or minus together, you should know that they shouldn't mix, okay? The indices that we learned previously, or the laws of indices, remember, if there's any subtraction of power, it has to be a divide here, okay? So if you want to revise, you can go back to the previous video and see why, which I'll explain why. If it's a division, then only you can minus the power. But anyway, in this case, there's a plus or minus in between. There's nothing you can do. The only way you should simplify is to rely on your calculator now. This chapter will require you to rely a lot on your calculator to do the first step of evaluation. Just to see what your calculator returns you. So once you punch everything in your calculator, you are going to get 1.8 times 10 to the power negative 10. So it's very straightforward. Look at 5e. Let's look at 5e. You have 2 times 10 to the power negative 5 times 6 times 10 to the power 7 over 4 times 10 to the power negative 8. Right, over here, if you want to do some manipulation, you can. Why? Because all are multiplication, times, times, times. You don't see plus or minus in between, which means you can do your division. So 2 divided by 4, you have 2 in the denominator, and then you can divide again. That's where you get 3. And then look at this. You are left with a 3, right? On the numerator. Then this is times 10 to the power negative 5 times 10 to the power 7 means plus 7. and this is in denominator, so it's a minus because it's divide by minus -8 in the denominator. So this one, without a calculator, you can get 3 times 10 to the power of